Continuing on with our statistics unit with graphs and different things, we're looking at this time line graphs, stem and leaf plots, and circle graphs. So first let's take a look at line graphs. They show trends over time or relationships between two things that can be useful to predict future events. Now we've done line plots before. That's with the x's. Line plots are different, putting little x's over the data points. This time we're doing line graphs. These are the ones that you know of where you use a straight edge to connect the dots and make a line. So in this example, we've got the relationship between temperature in Celsius and temperature in Fahrenheit. So to read this, we've got degrees Celsius on the x-axis, Fahrenheit on the y-axis. Our title is temperature. We're just going to come, if it says if 32 degrees Fahrenheit is freezing, what is freezing in Celsius? So then all we have to do is come to the Fahrenheit side and find 32, and it happens to be this point right here. And then we're going to follow that straight down to the Celsius axis and see that it is 0. So 32 degrees Fahrenheit is freezing, and 0 degrees Celsius is freezing. All right, now the next question then, predict the temperature reading from 35 degrees Celsius in Fahrenheit. So we're going to look at degrees Celsius is on the bottom. We'll come over here to 35. We'll follow that straight up to wherever it would cross the Fahrenheit line. Now you can see that they only plotted out Celsius up to 25 degrees Celsius. Okay, so what you would have to do is take a straight edge and extend your line out until it crossed the 35 degrees Celsius line. And that would happen here around 95 degrees Fahrenheit. So we're looking at an approximate temperature here of 95 degrees Fahrenheit. Line graphs are not always straight lines though. Sometimes showing trends over time, like in example 2, you're going to have the line going up and down. This graph is an example of store traffic. That's how many people in the store. The bottom part is time of day. The left side, the x-axis is time of day, and the y-axis is customers in the store. So the question is asking between what two times did the store experience the most drastic change in store traffic? That means where was the line the steepest? And if we look at this graph up here, we'll see that probably the steepest part of this graph is in between here and here, these 2 points, which translates to 2 o'clock to 3 o'clock. So 2 p.m. to 3 p.m. had the most drastic change in store traffic. And then we can talk about why we think that might be. Look how at 11 a.m. the line really starts going up steeply and then drops off sharply at 2 o'clock. And we can talk about why that is. It might be because of lunchtime. It might be, you know, lunch is over at 2 o'clock for almost all business people. And it might be that, you know, at 2 o'clock moms are getting ready to go pick up their kids from school, so they leave the stores, that kind of thing. All right, in example 3, we've got 2 lines going here. One represents Broward County, one is Miami-Dade. And then you can compare the two. So the question asks, how much larger was the population in Miami-Dade County than Broward County in 1980? So we're looking at 1980, that's this part right here. And we have to estimate because we're not going to be able to get exact numbers, except for this Broward County is right on 1 million. Miami-Dade is probably about 1,600 or 1.6 million, maybe 1,700,000. I'm going to say 1,600,000. And then Broward County was 1 million. So we've got a difference there of about 600,000 in 1980. Now we're going to talk about stem and leaf plots. Stem and leaf plots. We're going to use a table like this to do our stem and leaf. And if you look over here, it says chick weight, and that is a data table right there. And then you're going to take your data table and put it into a stem and leaf plot. Now what the stem and leaf plot shows, the stem is your tens places, 0, 10, 20. Going down here on the stem, 0, 10, 20. Your leaf is your one spot. So when I have a single digit like the number 5, its tens digit is 0, 0, 5, right? So underneath the 0 stem, I'm going to put a 5. Okay, if I have a number like 12, its tens place is a 1, and its ones place is a 2. So I'm going to put the tens place here, and I'll just fill in my ones place as a 2 over here. This would make 12. 10 and a 2 makes 12. A 0 and a 5 makes 5. A 2 or a 20 and a 5 makes 25. Okay, so the stem is your tens place. If I wanted to recreate these numbers from this graph over here, I would be able to say, okay, this is 0, 5, comma 0, 6, comma 0, 7 for my ones. And then I have 10, 11, 11, 12, 12, 12. Let's take a look at this making a table. So we're going to make a stem and leaf out of this data. We could start at the beginning here, and when you have your leaves, you want the ones places to try to be in order. Okay? If I have the number 0, I have to put 0, 0 here in the stem and leaf because I have to represent that that is one of the numbers in the table. So 0, 0 for 0 homework time. Then I've got a 5, that's a 0 tens place, and a 5 ones. Now let me look and see if I have any teens or tens. And I don't see any tens here. I am going to put a stem of a 1 over here, but my leaves are going to be blank, which means that I have no tens places. So now I'm going to go on to the 20s. So I have a 24, so that's a 2 and a 4. A 23, that's a 2 and a 3. I'm going to try and put them in order. And that's it for my 20s. I go on to 30s. I have a 30, that's a 3 and a 0. A 39, I'm going to put the 9 out here for 39. I have another 30, that's another 0 that goes in there. A 35, let me put my 5 in. And then that's it for the 30s. I go on to 40s. I have a 42, a 45 I see there, another 45, and a 45 down here, another 5, and a 47. Then I go on to 49, and I think that's it for my 40s. Now I'm on to 50s. I have a 51, a 55, 56, 58, and then no 60s, but I do have two 75s for my last two numbers. Okay, I've got all my numbers filled into my stem and leaf. Now I can look and see what is the range of my data. My high end is 75. That's the last number that's in here. And my low end is 0. So my range is 75. Is there a mode? Well, it's easy to look at your leaves and see if there's a bunch of numbers that are similar in a row. Right here I have 3 5s in a row. This represents 3 45s. So 45 is the mode. And what is the median? You're just going to count back to the middle right here on the stem and leaf plot. You might want to write these out in order if this confuses you, but you can go back from the middle. And 45 is the median also. All right, so then you can make assumptions based on a stem and leaf plot. Based on this data, what can you infer about pasta consumption? I want you to write something in here. And what is the most common amount of pasta consumed? So this is the most is the mode. So we try to find the mode there. Go ahead and write that in. And now let's talk a little bit about actually, we're supposed to be talking about scatter plots today, so let me see what we got here. But we have circle graphs. So let's just talk about these circle graphs. So for circle graphs, we're going to see how a whole is divided into parts. And each sector is measured using a central angle. Central angles then, when you have a circle, and I have a dot in the middle, and I have a sector that looks like a piece of pizza. Okay, that's a sector. This angle here that's right here on the center, if I measured that with a protractor, that would tell me the number of degrees in that sector, and that is the central angle. The whole circle and the inside of it are the circular region. And then you could also use percentages. Say this is 20% of the circle. Okay, and all the degrees in the central angles of your circle should add up to 360 because there's 360 degrees in a circle. So remember that if we're calculating the percent of something, it's percent over 100 and part over whole. Okay, and then you can cross multiply and divide to figure out what that is. So for example, if I have this number of people and this many snacks, I surveyed 50 people, so my total down here should be 50 people. My proportion then would be 20 out of 50 people like popcorn. So how many percent is that? So that would end up being 2,000 divided by 50, or 200 divided by 5, and that would be 40%. Okay, the candy bar would be set up as 15 people out of 50 like the candy bar, and what percent out of 100 is that? 10 people out of 50, and what percent out of 100 is that? And then 5 people out of 50, and what percent out of 100 is that? Okay, so I can tell you that this is 20%, this is 30%, and this is 10%. Now my percents should add up to 100 also. So when I look at this, I have 40 and 30 is 70, plus 20 is 90, plus 10 is 100% of my snacks. All right. Now, we can also take our percents and calculate degrees. So if I have something that's 20% of a circle, okay, 20% out of 100, and how many total degrees are there in a circle? That's 360 total degrees, and I put X on the top. And now I can calculate by multiplying across 20 times 360 and dividing by 100 to tell me how many degrees that would be. So in this one, in this same thing here, I had 20 out of 50. My percent here was 40%. Okay, so this was 40% if you look back at the original table. And that gives me 40 out of 100 for my percent and X out of 360 for my degrees. And I can go through and calculate the degrees. The candy bar was 30%, so that'd be 30 over 100 and X over 360. The trail mix was 20%. Okay, so I want you to go through and set up these proportions and calculate the amount of degrees in the middle of your circle. And then we would come in here and label these with the number of people, the percent amount, and the degrees. So this one obviously is the biggest one. It's the 40%. Okay, you would label the number of degrees that you found from the last table. This was popcorn, I believe. Let's go back and look. Yeah, and there were 20 people. So we would put a 20 in here. We'd label it popcorn. 20 people, 40%, and then we'd write in the degrees that we found from the last one. The next one would be the 30% category. This is the 20% category and the 10% category. And I want you to go ahead and fill these in with the rest of the labels that we calculated. All right, so you are going to work on your assignment for this evening, and we'll talk about this more in class if we need to.